Hello everyone. In this video, we are going to talk about conditional statements. But before we get into conditionals, we need to talk about code blocks. A code block is a set of code grouped together in some way. Some examples would be code under conditional statements, under loops, functions, classes, and so on. Code blocks are how we ensure that code executes only within the scope that they are meant for. In languages like C++ and Java, code blocks are contained within curly braces like you see here. This is just some pseudocode. It's not true Java or true C++, but it is a good pseudocode example of how it would appear. And as you can see here, we got two curly braces and all the code contained within. And I purposely made this indent off from the rest of it just to show you that in Java and C++, the indentation doesn't matter as long as everything is contained within the curly braces. Java and C++ can both understand that all this code will only ever execute under that if statement. In Python, code blocks are contained by indentation level. The size of a single indentation can be of any length as long as it's a minimum of one space. For Python, the recommended indentation size is 4 spaces. The first indentation that Python comes across in a code block pretty much defines what Python should expect for the rest of the code block. Even if code blocks are nested, they are treated separately when Python checks the indentation level. With that said, it is highly recommended to use the same size indentation across the entire program. And in this section here, we have a couple examples of indentation levels. In this first if statement, we've got a level of 4, so there's 4 spaces here. And then here, we've got an indentation level of 2. These are all technically under the same block, the same main block, which is this entire square here. So if we run it, it will run just fine, as you can see here. It's important to ensure that all lines are indented properly, because if you use incorrect indentation, two things can happen. Either the code will crash, or certain code will get executed when it wasn't meant to. And here, the example we've got, this code will crash because the code block for this if statement is expecting an indentation level of 4 because this first line has 4 spaces here. However, the second line was only indented by 2 spaces. So if we run it, we get an indentation error. So this is an example of it crashing. When you're working with a bunch of if statements, especially nested if statements, it can sometimes get a little bit confusing what level certain lines of code should be, especially when you have a lot of code under those if statements. So sometimes things will fall out of place and then execute when they weren't supposed to. So let's say that second line was actually supposed to be part of the if statement, but you forgot to indent. So if we put it out here like this, then even if the statement is not true, that code would get executed because it didn't fall under the if statement like it was supposed to. For this is just a print statement, so nothing bad really happens except a message will get printed. But sometimes you might end up setting data that wasn't supposed to be set if the statement wasn't true, and then that can mess up your whole code. Now on to conditionals. Let's start with the standard if statement like you see here. I've already demonstrated the if statement a few times in previous Python videos, but this time you'll get a walkthrough of it. If statements are what we use in order to control whether or not code executes. Here I have a pretty basic example of an if statement, and it pretty much represents its basic syntax form too. We have the keyword if, and then after if is the condition that gets tested. And if that condition is evaluated to true, then everything under the if statement will be executed. If it evaluates to false, then nothing happens. This is a very basic condition that's evaluated. It's basically checking to see if the condition is true. But since the condition is literally a variable set to true, it's going to execute and print this message. Likewise, if I was set it to false, then nothing happens. And even though that was just a basic example, there will be plenty of times where you are just evaluating if the literal value of something is true or false, whether it's a variable or the result of a function that returns a Boolean value. But if statements will not always be this simple. They will, more often than not, contain statements that will actually need to be evaluated and will often involve using conditional operators. Yes, we have more operators to learn, but don't worry, this is the last of them. So I've got a whole bunch of different examples using different operators, and we'll go through them one by one. So the first one here is Boolean equals. Boolean equals is used to check if two values are equal to each other. Special note with this one, be sure to pay attention when you use this in a conditional. It's uncommon, but programmers will often sometimes mix this operator up with the assignment equals operator. Fortunately, unlike some other languages, Python will give you an error if you try to use the assignment operator in a conditional. So at the very least, you don't have to worry about something weird happening in your code. The next one we have here is the Boolean not equals. This will basically check to see if two values are not equal to each other. And these next two are pretty straightforward. It's a less than and greater than. It basically checks to see if a value is less than the other one or if it's greater than the other one. And then these last two operators right here, which I have two examples of each, they check to see whether or not it's greater than or equal to or less than or equal to. So we got the greater than equal to here, and we got the less than equal to right here. So all these conditions will evaluate to true. So we should see all of these messages print out. And as you can see, x is in fact equal to 2, x does not equal y, x is less than y is greater than x, y is greater than or equal to x, y is also greater than or equal to 3, x is less than or equal to y, and x is less than or equal to 2, which as you can see up here is true. These operators are not just for integers and floats. They can also be used on other data types as well, though how they work depends on the type. For example, with strings, Boolean equals and Boolean not equals will still check whether or not two strings are the same. However, the other operators will have a different effect on the strings. They will compare the ASCII numeric value of the characters in the string from left to right. This is not going to be the same as comparing the alphabetic order of two strings though. All lowercase letters on the ASCII table are going to have a higher value than any uppercase letter on the ASCII table. So for this example here, obviously these two are straightforward. They're going to check if these strings are equal to these variables. For this one, however, we got y is less than or equal to x. So x is frigate with a capital F and y is cruiser with a capital C. So an uppercase C has a lower value than an uppercase F. So this will evaluate to true. So in this one, it's going to check to see if Z is greater than or equal to X. This will evaluate to true because Z is equal to destroyer with a lowercase d. And all lowercase letters on the ASCII table have a higher value than all uppercase letters. And then in this one, it's going to check to see if X is less than ZZ. And this is going to evaluate to true because even though they both have a capital F, the second letter, X has a lowercase r, but ZZ has a lowercase x. And the X is going to have a higher decimal value than the R. So if I run this, and as you can see, they all print out because they all evaluated to true. Now let's talk about some conditional keywords. They are technically operators as well. However, in Python, they are actual words instead of special characters, so I tend to refer to them as keywords. Let's start with the keyword is. The is keyword is used to test if two variables point to the same object in memory by checking their ID values. This is particularly useful because data types themselves have unique ID values when a program starts, because they are stored in memory as well. The is keyword can be used to help us verify if data stored in a variable is a particular type. In fact, I showed an example like this in a video covering the type function. So I'm going to bring that example up again, but I've also added a few extra lines in the example to help better demonstrate what is happening. So I've got two variables here, x and y. X is equal to frigate and y is equal to x. And in these four statements here, they're going to print out the ID values. The first two will print out the ID for the string type, and then the second one's going to print out the ID of the type x. And since the type of x is string, then that ID value should match what is printed out for string. And then the last two are going to print out the ID values for both x and y. Those should be the same too because we set y equal to x. So if I run this, and as you can see, the first two numbers, they match. And then these two numbers right here, they match as well. And it prints out the message x is a string and y is x. The next keyword is not, which will take the result from an evaluated conditional statement and flip its value. True would be flipped to false, and the code block would not execute. False would be flipped to true, and the code block would be executed. I've got an example right here where we got x equal to a. And then I got an if statement here where we say if not false, it's going to print not false. And for this example, strings have various functions we can call upon to check certain things or perform certain functions. This one here is checking to see if it's a numeric value contained in here. So if x was something like 1, 2, or negative 66 or something like that, and we use the is numeric function on it, then it will evaluate to true. But since it's the letter A, that will evaluate to not true. But we added a not in there, so it's going to invert that false into a true, and it's going to print out this statement here. So not false because we said if not false, and x string is not a number because we checked to see if it's a number, it returned false, not inverted that false into true so that we could print out the message to say that it was in fact not a number. The not keyword can be combined with the is keyword as well. So we've got x equals 1, and we can say if type x is not string, then print out x is not a string. So we're combining the is and the not together. So we're basically saying, hey, check if the ID value is not string. So if we run this, it says x is not a string type. The last two conditional keywords are and or. These keywords allow us to evaluate multiple conditions in a single if statement. There's no real limitation for combining conditional statements, and you can even nest conditional statements with the help of these two keywords. For the AND keyword, the conditions on both sides must evaluate to true for the whole statement to evaluate to true. For the OR keyword, only one condition must evaluate to true. So we got two variables here, x and y equal to 6 and 8. And in this first statement right here, it's checking to see if x is divisible by 3 and divisible by 2. Since modulo returns the remainder of a division equation, these will both return 0 because 6 is in fact divisible by 3 and divisible by 2. In this statement here, we're checking to see if x is divisible by 4 or if y is divisible by 4. So obviously 6 is not divisible by 4, but 8 is. So this part will evaluate to true, whereas this one will evaluate to false. So either way, this print statement will still print. So we run it, and it prints. Another thing to mention about these two keywords. Python supports a technique referred to as short-circuiting, which basically means Python will stop evaluating conditions as soon as it is able to evaluate the Boolean result. For the AND keyword, since both conditions must evaluate to true for the whole statement to be true, as soon as it discovers a false condition, Python will immediately evaluate the whole condition to false. For the OR keyword, since only one condition needs to be true, as soon as it finds that true, it will evaluate the whole thing as true and stop evaluating all the rest. So in this statement right here, we've got an AND statement, and we're basically evaluating W to check if its ship type is frigate and its ship name is Hawk. So when we run that, it will come out as true and print this statement here. For this one, it's going to check to see if Y's ship type is either cruiser or cargo. And since it is cruiser, the moment it evaluates this line, it's going to print this out. It won't even bother checking this one. See? You can't actually see short-circuiting in action, but it's easy to demonstrate where it would actually stop by putting something up like this. So if I were to change this W to Z, when it checks the ship type and sees cargo, it's going to stop right there because this AND statement means that if this is false, the whole thing's going to be false anyway, so there's no point to checking its ship name as well. Now, sometimes we have a situation where not only do we need some code to execute when a condition evaluates to true, but to also execute a different set of code when it evaluates to false. This is where the else keyword comes in, which allows us to make if-else statements. So I've got an example right here where we're checking the ship type. It's going to check to see if the ship type is frigate, and if it is, then it'll print out this statement. If it's not equal to frigate, it will print out this statement. So if I run this here, it prints out the first message because it was in fact equal to frigate. But if I change the ship type to cargo and then run it again, it will print out the other message. It's very important to make sure the else statement is on the right indentation level as the if statement it's supposed to be paired with. If you have nested if statements, you can sometimes unintentionally match that else with the wrong if statement, and then things will not execute properly. There will also be times where we have to evaluate multiple conditions that can't be true at the same time. This is where the keyword elif comes in, which is short for else if. Like the else keyword, this must be preceded by an if statement. It allows us to specify other conditions to be checked in the event that the previous conditions evaluated to false. And as you can see here, we can specify as many else if statements under a single if statement as needed. As you can also see, we can also use the elif and else keywords together under a single if statement. However, there can only ever be one else keyword at a time. It must be the last condition every single time. So if you see here, we've got an X with the ship type frigate and the ship name Hawk. We are checking the ship type here, and depending on which ship type will determine which docking bay it's going to go to. Or if it's none of these, then it'll just say, hey, it can't dock here. So for this run, it's going to say go to docking bay 1. And if we change it to cruiser, and then run it, he'll say go to docking bay 2. Same with cargo. Go to docking bay 3. But if we say minor ship, it will say it's not compatible because that's not an option for it to check. And that's it for conditionals. I hope you've enjoyed this video and found it helpful. And if you did, then please hit the like button and leave a comment below to let me know what you think. If you want to see more, then head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.